Hey guys, welcome to my video on the remainder theorem and the factor theorem. So in this video, I will mainly talk about the remainder theorem, and in a separate video, I'm going to talk about the factor theorem. Okay, so let's start. So by definition, the remainder theorem is if p of x, which is a polynomial, is divided by x minus a, then the remainder r of the division equals p of a. Okay, so let's all explore what that means. So for example, it says use the remainder theorem to determine the remainder when p of x, this polynomial, is divided by x plus 1, also another polynomial. All right, so we know that we can only use long division, sorry, not only, but we can use long division or synthetic division in this situation to determine the remainder, right? So that's what you know, and that's all you know for now. So let's do synthetic division because it's in the form of x minus a. Okay, so I'm going to draw a box, and in this box, the number should be -1. And then I'm going to write out my coefficients. So making sure that this is in standard form, which it is. All right, so I've written all my coefficients now. I skip a line and I draw a line. Okay, I'm going to perform my synthetic division just as how I've explained in the previous videos. So I'm going to bring down my first term, that's 1, then multiply number in the box with this number, place it under the next coefficient. So that's going to give me -1, and then I add 5 minus 1 is equal to 4. And then I multiply and repeat the process over and over until you get to the remainder, right? So -1 times 4 is -4. Okay, then I'm going to add -6 and -4 becomes -10, and I will multiply. So I don't want to ruin this whole color scheme here. So -1 times -10 is +10. And then 5 plus 10 is 15. And in theory, that should be, if you checked it correctly, that should be your remainder, 15, right? So okay, so that's what you know. You know how to get the remainder if you use division. But if you use the remainder theorem, there's actually another way that you can check that you're correct about your remainder. So we can apply the remainder theorem. If we apply this number, which is this number, back into the equation, we should be getting the same remainder. All right, so if I take p of -1, okay, so plug this number back into the equation for this x, and this x. In theory, my remainder should be 15. Okay, so that's the basis of remainder theorem. Okay, so let's begin. So x cubed becomes -1 cubed plus 5 times x squared becomes -1 squared minus 6 times -1 and then plus 5. And again, the reason why we're plugging in a -1 is the same reason why we would have put a -1 in that box. Okay, it's the number that makes this equal to 0. All right, so let's evaluate. -1 to the third power is -1. -1 to the second power, because remember, you want to square first before you multiply by 5. So -1 squared is +1. So I'm going to color this red. +1, and then +1 times 5 is equivalent to 5, +5. So add 5. All right, let's keep going. -6 times -1 is equal to +6, and then +5. Okay, so let's add up all these numbers. -1 plus 5 is 4. 4 plus 6 is 10, and 10 plus 5 is equal to 15. So they match. So that's what it means. If you plug in the same number here, you should back into the equation, you should get that remainder. So in theory, you don't really need to use synthetic division to find what the remainder is. You can actually just plug in the number you would have put in this box back into the equation, and then you will eventually get your remainder. Okay? All right, let's take a look at another example. Okay, it says practice B, if p of x is equal to x cubed minus 2x squared plus 8x minus 3, and that's being divided by x minus 2, then what is the remainder of the division? Okay, so again, we don't have to do the actual division to find out the remainder, but if you would like to, you are more than welcome to. Okay, so we're going to plug in a 2 in this x, and this x. I should get the remainder. So p of 2 is equivalent to 2 cubed minus 2 times 2 squared plus 8 times 2. And again, we're plugging in a 2 because it's what made this equal to 0, right? So then minus 3. All right, let's evaluate. So 2 to the third power is 8. 2 to the second power is 4, and 4 times negative 2 is negative 8. All right, so I'm going to put 4 here times negative 2, and that's how I got the negative 8. Okay, now 8 times 2 is 16, and then minus 3. Let's add it all up. 8 minus 8 is 0. 16 minus 3 is 13. So P of 2 is equal to 13. That means 13 is the remainder. Okay? Without you doing any division whatsoever. All right, thank you for watching my video on the remainder theorem.